How did I come up with this idea? Well, I was looking at maps of the moon, and I thought, it is really non-intuitive as to where, if I just take a snapshot, it looks like everywhere else. Really, all you're going to see are a lot of craters, and there are not really a lot of distinguishing features on the moon other than maybe an occasional rill or a mountain, but it's mostly craters. And so I kind of got lost up there, and I thought, we're missing some kind of navigation element. What are we missing? And that's when I thought, we're missing roads. We need to start to think about these transport routes. And I found some research that was done by SkyCorps back in 2012, and they charted the low, medium, and high slope routes from the rim of Whipple Crater at the North Lunar Pole to the floor of Peary Crater, and they chose that location because Whipple Crater is in what's known as the peaks of eternal light. So it's always light, so you always be recharging your solar batteries, and and so I thought, well, of these three, which is optimal for what we want to do? And although Route 1 and 2, the high and the medium slope, look shorter, probably you're going to have switchbacks. So I decided that for our purposes, we want to focus on the low slope routes with gradients of 15 degrees or less. And so our first road, I named for those two researchers, I called it Wing-O-Ep Circle. And we start at the peaks of eternal light at Whipple Crater, and we make a loop down into Peary Crater, and that is where you can find water ice. And as I pointed out, it's a great place to build a lunar base because of the ability to be in the sunlight all the time. So here is our second road, and this is a highway. And so what I did is I started at the peaks of eternal light, again at Whipple Crater, and I went all the way for about 1,600 miles to Oceanus Procellarum. And Oceanus Procellarum is thought to be a promising area for mining, and in particular, it's thought to have a lot of helium-3. And helium-3 is the foundation for an experimental form of energy, fusion energy, and although they haven't done that yet, it shows a lot of promise, and it is probably the best model for deep space manned exploration, fusion energy, and helium-3. So here we have the third example, and this is kind of in honor of the Apollo 11 mission and the first man to walk on the moon. And so we start at the Apollo 11 landing site, and we go out to Armstrong Crater, and we cross the Sea of Tranquility, so I called it a bridge. Why not? And so this is Neil Armstrong Bridge, and this is the third lunar road within the context of the planetary address framework. So here is our poster, and so now you start to see why we chose this iridescent blue and green and yellow, because it represents light, and light is a key enabler for life beyond Earth, and we kind of juxtaposed that with the grayscale moon and came up with this beautiful poster. Over here on the left, you see the definition of the Eskey system, and then you see the names of the roads, and you see the address. And there's a blank space at the top where our clients can put their logos and give these out as promotional giveaways.